This Venn diagram shows the teenagers in a group who like tea and or coffee. So Bob, Alan and Kelly like tea. Sarah, Elaine, Trevor and Helen like coffee. What is the probability that a teenager chosen at random likes tea or coffee, likes tea and coffee? So let's start off with tea. So what's the probability that a teenager chosen at random likes tea? So part one, we're trying to find the probability that a teenager picked at random likes tea, i.e. set T. Well, the number of teenagers in set T is 3, and the number of teenagers in the universal set is 7. So this is the universal set. So there's 1, 2, 3, 4, 5, 6, 7 teenagers in total. So the probability that the teenager will like tea is going to be 3 over 7. Part 2, that they like tea or coffee. So we're trying to figure out the probability that a teenager picked at random likes tea or coffee. So very important to note that in probability, or means add. So it's going to be the probability that they like tea plus the probability that they like coffee. So this is really the union of the two sets. So there's 3 of them here, 4 of them here, so 3 plus 4 makes 7. So or means add in probability. So the probability that they like tea or coffee is 7 over 7, which is 1. So it's definite that one of the 7 students likes tea or coffee. It's certain or definite, because a probability of 1 means certain or definite. Part 3, what's the probability that they like tea and coffee? The next solution shows an example of mutually exclusive events. Mutually exclusive events are two things that cannot happen at once. So for example, it's raining and it's not raining. They are mutually exclusive events. Now the probability that someone likes tea and coffee is not actually mutually exclusive. Someone can like tea and coffee, of course, but in this particular example, there is no name in set T that's also in set C. And these two sets do not overlap or intersect. So we're trying to find the probability that a teenager picked at random likes tea and coffee. This is the intersection of the two sets. While there is no intersection, the two sets do not overlap. So the probability that they like tea and coffee is going to be 0 over 7, which gives us a probability of 0. So there is no chance, there's a 0 chance, 0 probability, there is no chance that in this particular example there is a teenager that likes both tea and coffee.